All right, welcome everybody for this second session of what we are now calling a kickoff presentation of round one of deep funding, where some of our awarded candidates, the people that you have selected, are presenting what they are set out to build over the coming weeks, months, and well, we'll see how long it will take. I think we have some very interesting and exciting projects for you here today. And what I like about this group, but also the bigger group in general, it's that it's so diverse. So we'll have very different kind of projects, and but we'll just go and see how that works out. And we'll start with the first one, which is Anti-Fakenews analytics app by Jan Romportel.
Yep. Okay. Thank you for the introduction. Now let me see if I can do properly screen sharing. Do you see the screen already?
Yes, I can see it clearly.
Okay. So I've prepared this short presentation to tell you a few words first about like the Mawu project as a whole, and then the sub part like supported by the deep funding project. And then if you're interested in some potential discussion, we might discuss the specific things about fake news and the truth and stuff like this. But now first things first. So in Mawu, what we're trying to do is to build a fair and sustainable anti-fake news system. And it's because there is a challenge with typical AI systems that try to tackle fake news, which is first, they lack a sustainable funding model or business model. They suffer from centralization, and it makes them manipulable, and it makes them much less trustworthy because people indeed just don't trust them because they just think that it's, something manipulating them anyway. And this is the most important part, they struggle with user motivation. So why would anyone use anything to tell them that they read whatever kind of fake news, because they probably read it like to read that kind of news. So this is very tricky. We're trying to address this by the project, like the first part, the decentralization. We've decided to, because the back end of Mawu project is a lot of machine learning models, mostly from the domain of natural language processing, but many other different models. And for us, the SingularityNET like ecosystem and SingularityNET machine learning marketplace seems like the best idea to gradually deploy our machine learning models to, so that they can be like auditable. Basically, like people can people and other interested parties can just query them and use them for their own purposes, for their own products. But they're like more auditable by the community, and it's much more clear what's behind them, as opposed to the situation where they run on some centralized server somewhere hidden, and nobody really knows what's happening, and who is training them, what their characteristic is. So for us, so this is one of the reasons why we decided to put it on SingularityNET. Well, the other reason is that we just simply like SingularityNET and its idea. And the third reason is that I've been like kind of following enthusiastically Ben Gertz like for last 20 years. So this is it. Well, the second challenge is the user incentivization. We work on that project with some psychiatrists and psychotherapists from the Czech National Institute of Mental Health. So there are like many different ways how to motivate users. I will not speak about most of them here. The Mawu project is specifically trying to explore the idea of kind of play to earn strategy to incentivize the people. Simply, I mean, it sounds almost horrible, it's blunt, but just give them money to interact with it. If you just tell somebody, look, there might be some hate speech in this article you're reading. If you find it for me, why not give you just $1 or something like this, So and the point is to teach people avoid the Kahneman short loops, like shortcuts of thinking, and just to motivate them to think, twice before just blindly accepting what they're reading. So this is the user incentivization part. And now we're going to where Mawu deep funding project lies in. Indeed, if we want to financially incentivize the users, you need to get money from somewhere. So we want to build the ecosystem that is able to generate the revenue on one side of that ecosystem. That one side could be like revenue generated from third parties using our machine learning models deployed on SingularityNET. This is one pillar. The other pillar could be like around Cardano ecosystem and stake pools operated in the Cardano ecosystem. And the third pillar and other pillars could be like monetizable applications, our monetizable applications built on that same ecosystem that generate revenue, and that revenue is redistributed as a motivational element to the end users. And this is exactly what we're building here in the deep funding project. We call it Mawu.Analyst. And it's like the end user facing front end, like a detailed analytical dashboard for easy and user friendly access to all fake news related insights generated by the core Mawu system. And so imagine something like a Grammarly for like writing things. So this is like pretty similar, like metaphorically similar, but for reading news articles. You get like a very detailed dashboard integrated in your web browser that queries machine learning models deployed on SingularityNET. And it's a subscription-based application like built on top of Cardano. And the subscriptions collected from the users of this this application with many functions are then redistributed back to the regular users who use a little plugin, just a little assistant for reading the news. So this is basically what we're building in this deep funding project. So it's the front end part, like a detailed analytical application. Just the last thing. We're not fact checker. We're not a fact checker. We don't do the fact checking, so that there are other nice projects trying to do fact checking. We don't do the reputation of the sources. This is like there are other interesting projects. I think they're even around the SingularityNET ecosystem. So we will be happy to plug to those. We don't judge the truth, but the truth is out there. And it's very often very difficult to get to the truth. It might be like so difficult that it's almost impossible to describe it by natural language, but it is still there. Like the context might be very difficult. The problem with human minds is that they're not they have not evolved as truth-seeking machines. They have evolved as catchy story-seeking machines. And there are like lots of malicious online content that with injected kind of things that basically hijack your ability to seek the truth and mislead you with those kind of manipulative catchy story things. And this is what we're trying to detect. So we don't tell you if the article is true or not, because very often it's just not possible to identify. And we're just trying to tell you if the article contains things that try to hijack your mind, basically. Yeah, that's it. That's
Thank you.
all for me. Thank you.
Thank you, Jan. Yeah, I think it's a great product that the world definitely needs. I honestly think that this is actually one of the biggest problems in our society right now, that we don't all start from the same basis of what the truth is. If we all would agree on what the facts are, then it's much easier to have a discussion on what to do. So how would you go about if a number of people have reviewed a page or whatever, and then 5% says this is clearly manipulative, and 10% says no, this is completely straight? Then what would your advice be in such a situation?
Well, for this part, like the future development of Mawu is really about this kind of crowdsourced machine learning for that. It's a very difficult thing, like very difficult thing, because we don't want like malicious actors to basically like hijack the system as it is. So at this moment, we like really we have like a large group of annotators that like manually annotate like lots of news articles. So you might basically object that the system now at this moment basically machine learns their way of seeing the world. That's it. That's right. That's right. But you know, there is no other way how to start. So we're starting this way. And then when we see what the interactions with the community are, what the user behavior is, we'll slowly and very carefully try to introduce like more decentralized and crowdsourced ways of like governance of the system.
And is that
but we're really indeed afraid of like malicious people trying to, you know, to steal it somehow.
Yeah, especially in the starting period, that would be very tricky. But this is also where it ties into the weighted liquid rank reputation system that you mentioned, of which I'm a big fan.
Okay, yeah, sorry, I just saw that there's like Natasha's question. I don't know, will we go to that part, or?
I didn't see that, so
yeah, I was just I just noticed it in the chat. So
please. So Natasha is asking, are there keywords or absolutes which most often show opinion over fact? That's an interesting.
Well, we have machine learning model based on language models that tries to identify whether it is like a news article or opinion article, essay, and things like this. At this moment, we put aside opinion articles. We try to detect if the article is actually an opinion article trying to pretend that it's a news article, and we kind of display this thing. But well, it's not 100% you know, accurate. Sometimes it doesn't work, but it's still work in progress.
Well, I suppose the good thing is that you're using human judgment, right? Assessment in these articles. So it doesn't all have to be machine learning, but it's a human interpreting. Of course, that's also the tricky part, but it, yeah, probably needs to be a mix. Does that answer your question, Natasha?
Yes, thank you so much. I kind of, you know, when I'm doing my research, I look for keywords. So it's almost like postmodernist rhetoric. And as soon as I get that postmodernist rhetoric, I know that it's opinion. And then I try to look at the resources for facts. But as far as this is concerned, there are very well-known newspapers and magazines that come under the genre or the interface of news, which are largely politicized or polarized, and one is the Federalist, for example. And anyone who reads the Federalist knows that it uses certain words as hyperbole, then those words are absolutes. They are, you know, rather than it seems, or in our opinion is, or in our observation is that they are. It's like those expletives, they are, or it is, are really qualifiers for that. The quantifiers is not so easy because, you know, percentages and numbers are quite good to have in articles. But are you, my question is here to follow up on that, and then I'll be quiet, but it's, there is a known certain resources that are hyperbole. like the New York Times, or I don't know about the Daily News in the UK or any other country, but the Federalist is very religious and polarized. Reason magazine is very objective. So do you have a list of categories of the most obvious magazines or news sources that are determinedly and obviously slanted? And then people, you could say, well, this is the slant from this particular viewpoint, and then still have the article. Like when I go back and forth between CNN and MSNBC and BCC, for example, I know they have a slant, and I listen to the news through that lens that this is a slant, but I do gather information that is, some of it is reliable, but I base it on the fact that it is polarized to start with.
Okay, we explicitly try to avoid using something like a score of the source. Like we don't try to generalize over the source of the articles. Well, that's one thing. We've started to develop the system like in the Central European context, Central European space. And at this very moment, it works on the Czech language, and we're gonna port it to English context. I mean, it's actually harder to do it for Czech because there are many more English language resources like training data for NLP. So it was harder to do it in Czech, so the porting won't be that hard. But I can tell you that for the Czech context, I mean, we really try to avoid that. But from the other cues, like we detect hate speech, stereotypes, call to actions, political biases, logical fallacies, so that there are like many modules. Every one of them is trying to detect the presence and or the degree of all those things. And then there is like a meta model, like creating like an overall score from those. So if you rank the local media according to, I don't know, the presence of the hate speech, you basically get something that you would intuitively actually guess that it, corresponds to that worldview. But we really try to avoid saying that if it is this media source that is known to be pro whatever, like in the Central Europe, it might be like pro-Russian or anti-Russian or whatever. We deliberately don't put this information into the model, so that if that media, if they write about, I don't know, pretty non-evil article about, I don't know, a city that just started to use new trams or something, and then it's perfectly okay that they probably get like a high score for that. And it increases the people's trust in that system, because I mean, if we score like low score to everything that goes from that media, then people wouldn't trust it.
Mm-hmm. Agreed. Thank you.
Wow, it sounds like a real minefield, trying to make an application that determines what the truth is, more or less. I know that's not exactly what you're doing. But yeah, I think it's also a journey, right? And then seeing what does fit and does not fit into the application. And maybe when time goes on and you mature, that will also become more solid. Yeah, we're already spending quite a bit of time on this. And I think this particular subject, we could easily fill the rest of the hour with, easily. We won't do that. I do have one or two practical questions, but yeah, would be served by a short answer, I think. First of all, is this related to the fake news app that was originally launched by NewNet as their first use case?
No, we found about their project while we were working on our project, but we already got together, discussed, some issues together, but these are like two independent projects. But right. I think it could be like we could use possibly the outputs of their system as one of the predictors to our models.
Okay, good. And what is now the status of your core application? Because what you're funded for is an add-on to the application, an analytics tool. So what is the status of your core application? Is that already working? Are there?
Yeah, it is working as a prototype, like non-public prototype for the Czech language. So it's definitely not production ready. So we would not put it somewhere and just let people use it. It doesn't have a user front end. This is the part where one user front end will be like a simple user front end for end users, and it will include a Cardano wallet for the micropayments as their incentivization, and the other front end will be paid front end developed within the funding project. So we don't have yet the front ends, but you can already query the models for the Czech language. But they at this moment they run in certain centralized virtual machine. So now the next steps are porting those models to SingularityNET. We're now running in some scalability things. So we need to like downscale some of the big language models. So these are like technical issues we're trying to sort out. So the step number one with the core Mawu is port I don't know if step number one, there are like two things: port it to SingularityNET, the modules that we now have. And the other part is create a free end user front end.
Great. Well, I'm glad to hear that you're porting those services also to the platform. That's what I was hoping to hear. There are many more sides to this that I could explore, but due to time, we won't do that right now, but maybe we'll have another opportunity. Oh, there's one thing for our community members, maybe might be interesting for you to mention right now. You will only be starting the work in September. Is that something that you would like to comment on?
Yes, I would. Actually, it's interesting, but now, like today, like we're now is Thursday. It's my last day working full time in a corporation, like as a director of AI center, where I really decided to go like full steam on this project. But now it's like a lot of things with handover and so we want, together with some people from my team, won't be available during the 2 summer months, like July and August, like fully available to be able to work on this project. So this is the reason why we kind of upfront pre-negotiated that we will start after the summer months, like in September.
Yeah. But that's actually good news, because the reason is that after that you will be full-time dedicated to this. Yeah. So I think that's a very good thing. And it fits nicely into our model where we disperse the amounts based on your milestones. So it's not really a problem if you start a little bit later. All right. High time to go to our next awarded team proposer, one-man team, I must say. Robert, you have not one, but you have won 2 projects from our community. So that's very special. And they're very closely connected. One builds on the other one. But yeah, I'm really looking forward to your own explanation.
Thank you very much, Jan. My name is Robert. I'm a student from Vienna. I have some background in biology, computational chemistry, and drug design. And that's where I got into contact with evolutionary algorithms for the first time. And my projects are about genetic programming, or a special variant of genetic programming. And I've actually had a prototype when I submitted my proposals. And since then, I've kept working on it. And a few days ago, I've released the early alpha version on GitHub. So after this talk, you can already try it if you want to. And in my talk, I want to give a mix of a project presentation and a tutorial how you can use the package. So it's a mix of a bit technical and a bit general. I hope it's interesting for everyone. And because I have to switch between different windows and type some text and so on, I have pre-recorded my presentation, because in a live conference setting, that's always a bit tricky. So I hope you don't mind it if my prior self gives you an introduction.
We'll lay back and enjoy the ride.
Thank you. So I'm sharing my screen. Hello. This is a shorter version of my original presentation. It will give you a quick idea of what can be done with my projects, while the original presentation explains in greater detail how it can be done with my package, and it will be available as a separate video in the style of a lecture and tutorial. I've recently uploaded an early alpha version of a software package for my first project to GitHub, so anybody with basic knowledge in Python is sincerely invited to try it out, and I'd really appreciate any kind of feedback in this early development phase. So in Deep Funding Round 1, I have proposed 2 projects, and I'm honored that both got accepted. I'm very happy and excited that I get a chance to implement my plans and add 2 or more services to SingularityNET. The first project is about a general purpose optimization service that can be used to solve hard optimization problems in many different areas, and on which you can build many practical use cases. The second project is one such use case, and it will use grammar-guided genetic programming to search for optimal trading strategies in infinite search spaces that are defined by user-provided data and preferences such as certain markets, indicators, metrics, and so on. Its unique feature is that both the form and parameters of a strategy can be evolved at the same time, while most existing approaches can only evolve the parameters of a fixed strategy. Therefore, it can find much more creative solutions that humans might not even think about. Now, let's jump directly into Project 1. The complicated title can be broken into 2 simpler parts, as you see here. In computer science, there is a field called evolutionary computation, which studies evolutionary algorithms. These are nature-inspired optimization methods that can search for solutions to hard optimization problems and often find very good ones in a reasonable time. As you see here, genetic programming is one of many subtypes of evolutionary algorithms, and what sets it apart from others is that it can evolve computer programs. Now, in classical genetic programming, which started mainly by the work of John Kosa in the 1980s, the form was rather limited because it could only evolve programs in a single language, such as Lisp, and only simple expressions. Since then, many modern variants were developed, and some of them belong to the category of grammar-guided genetic programming. These methods have in common that they use a context-free grammar to define a search space and an evolutionary algorithm as search method. What this implies is that they can evolve programs in any language which can be defined by such a formal grammar, which involves most modern programming languages such as Python or Rust, but also Atomise and Meta, which are the languages used in OpenCog and its next version, OpenCog Hyperon. Now, my project is about implementing 5 methods that represent state-of-the-art in the field, then benchmark them and bring the best performing one onto the SingularityNET platform. It can then be used to solve hard optimization problems, where optimization simply means to find the best option or candidate solution out of many possible ones. To do so, we need another ingredient, which is an optimization goal, and it is usually defined by a so-called objective function that gets a candidate solution as input and returns a score for it as output. So you can identify the best one simply by looking for the one with the highest or the lowest score, depending on whether you want to maximize or minimize in your optimization problem. Now, when you want to solve an optimization problem, you will have to define the search space with a grammar and the goal with an objective function. The search method is provided in the software package or the service which I will develop, and it will be able to find good solutions in many different search spaces, even infinitely large ones. The advantage of calling the service instead of using the package is that a service is language independent. So for example, you could develop an Android app in Java or Kotlin and call the optimization service that is written in Python. Another advantage is that the service will run on a powerful machine which can evolve many candidate solutions in parallel, while on a mobile phone or laptop it would take orders of magnitude longer and also drain the batteries. My hope is that over time, several use cases will be built on top of the grammar-guided genetic programming service, and I will provide the first example as kind of a template for others to copy. It will also be a demonstration of an inter-service call on the SingularityNET platform. To give you an example what a use case might look like, here is one of image approximation, where the search space could be defined by a grammar that specifies a small language, which allows to assign different colors and positions to 300 semi-transparent triangles. The goal could be to closely resemble some target image, which you could, for example, encode in an objective function by minimizing the pixel difference between the candidate and the target image. The evolutionary algorithm would then start from a population of random solutions and iteratively improve them until some stop criterion is fulfilled. This is another thing that the user has to provide, for example, in form of a maximum time that the algorithm is allowed to search, or in form of some fitness threshold that it has to reach, where the solution quality is good enough. So step by step, the algorithm will discover better results in a trial and error fashion, and if you let it run long enough, then it could look like the animation you have already seen in my proposal and also on the first slide. One specific feature of grammar-guided genetic programming is that it is very easy to define and change a search space. Here, for example, we could easily change the geometric shape from triangles to, let's say, circles, and the result would look quite different. We could also change the number of shapes from 300 to 150, and let's say at the same time switch the shape from circles to ellipses, which gives yet another result. Now the main point I want to bring across here is that it is easy to change the definition of the search space and apply the same algorithm on it without having to change its internals, such as the search operators or the solution representation. And this is exactly what makes this method very flexible and allows it to be used in any area where you are searching for some optimal configuration in a space of many possible ones. A second use case with more economic value is the search for trading strategies, and this is the topic of my second project. It is possible to apply exactly the same algorithm to a very different search space and try to reach a different goal. So the search space would consist of a lot or even infinitely many possible trading strategies, and it can be shaped by user preferences such as certain markets, indicators, metrics, and other requirements. The goal would be to find a trading strategy that performs well on historical data, which is actually often not that hard in most markets, but the difficult part is that it should also have a high probability to perform well in future live markets, and this is where the task becomes tricky. There are many pitfalls one can stumble into, but also remedies against them. Other people have already tried to use genetic programming for discovering trading strategies, and some reported good results in academic literature, but there are also reviews that explain why most of them would probably fail in live markets. One obvious problem are implementation errors. Part of my proposal is to test different backtesting libraries and see if they fulfill my requirements, but also if they calculate correct results. In the end, I might have to implement my own backtesting logic, where test-driven development is one way to improve code quality. With backtesting on historical data, there is also always a chance that some part of the system might implicitly use data from the future, and a remedy against that is doing simulated live testing, where you feed one data point after another into the system. Another classical problem is overfitting, which means that you discover patterns that are overly specific to the given data and won't generalize into the future. This is a known problem in all of machine learning, and there are many statistical evaluation techniques to counteract it, some of which also work on time series data. But in the end, the only way to really see if the discovered patterns hold in future situations is to actually test it on them. A more subtle problem is that you might optimize for the wrong goal. Essentially, we want to find strategies that deliver consistent profits in live markets without suffering major downturns. And this can be captured to some degree with risk-adjusted performance measures such as the Sharpe ratio or Sortino ratio. There are certainly many other subtle points, so part of the proposal is to do a thorough literature review to learn from mistakes that others have made and strategies against them. With that, I want to conclude my presentation and give you some links where you can find further information. If you're interested, there's also a second presentation which explains in some detail how to use my software package. Thank you for listening, and I'm looking forward to hearing feedback from you.
Robert, thank you for the presentation and the lecture. You made very clear what you're doing, but also how you're doing it. I also want to thank you at this occasion for this great visualization that you made for the voting behavior. I added a link to the blog that I created, and it's an interactive tool that shows you intuitively how the voting went on. So yeah, I really appreciated that. And yeah, I guess that's one of the outcomes that you can do with this abstract reasoning. So I was always focused on these two beautiful pictures that you were that were on your
animations, yes.
On your animation.
Eye catcher, that's true.
But there's a whole other world behind that, and I somehow get that now as well. I was telling you at the beginning that we have a very diverse collection of projects, which shows the first one with fake news app, detection app, and this one with genetic algorithms are quite different. But actually the next one from Cirque may have some overlap because it's also about text and grammar, right, Cirque?
Yes, it has, it's a lot simpler, but it has some similarities. All right.
Hit it.
I will share my screen to start quickly. My project is the universal sentence parser. It's about basically splitting a text into sentences. An easy example here is English language text that consists of 3 sentences, and I want to determine where the sentence starts and ends. This is a very simple example, but basically that's what my software should do. But there is of course a lot of existing software that does this, but it has some disadvantages, like it usually the alphabet is fixed, the language is fixed, or the dictionary. There's not many flexibility, and it's often quite slow if you want to really work with a very large text. For example, I would like my program to work with the complete text of Wikipedia, and I have to see how long that will take, but it should not be should not take days. And often it doesn't. There's no support for multiple interpretations. It may be possible that there are different ways in which you can divide the text into sentences, and I want my program to find all the different interpretations. Well, as input for my program, the user can define an alphabet. We already saw this in the previous lecture. For example, an alphabet consisting of A, C, G, and T, or just 0 1s, or of the letters of the English language. It also needs a dictionary of existing words, and it needs some rules about what ends the sentence. So in the English language, it would probably be a point, exclamation mark, or a question mark. But it can be anything, and it can also be more complicated rules. And then the requirements, what my program should do, it should allow the user to have a free choice of the alphabet, of the dictionary, and to define what makes a sentence a sentence. It should have a high performance. I plan to write most of it, or perhaps all, in the C language, and it should allow for multiple interpretations. So the outcome may be that there are more than one way to define text into sentences. And then very short roadmap. First, I will make a basic version that will not be too complicated. But my first milestone, and the second step will be to make it more advanced, to add some edge cases, to see how complicated it can get, and that it can also handle these cases. I think that was already it.
Thank you, Sigurd. That was quite a bit shorter.
Yes.
But actually also, interesting overlap there. So we could already test our knowledge from the previous thing in your proposal.
Yeah, you had a good order.
What I like about your proposal is that it's very clear cut, right? It's a very clear cut objective, cutting sentences, text into separate sentences. And not doing that just with natural languages, but also with programming languages, for instance. But maybe you could explain me a little bit better who would be the users of that tool.
I started to develop this for myself to apply it to the natural language of the Dutch language. I'm from the Netherlands, and I have been working on that. But in this case, to be honest, I'm not quite sure yet. I have a friend who works with DNA sequences, and he has problems where they have to do this kind of cut long strings up into short strings. So there may be an application, and basically anybody who wants to work with either a natural language or some kind of artificial language can use it.
Yeah, it can be a tool in a larger tool set around NLP, basically.
Yes, exactly. Yeah. I see this as the first step that you need to apply.
Yeah. Well, that is actually also a good example of what our platform can be about, right? It doesn't always have to be a full solution from A to Z, but what I see in the future is that our platform is also there for smaller, very dedicated, purposeful solutions that can then be used by a host of others. And your service is an example of maybe a rather abstract tool that might be used in a range of other solutions in the future. And that way, having one service talk to another that talks to another, hopefully using AI DSL in the not too far future. So, I think that's also a nice perspective. So it's similar to Robert, but on the other hand, it's also different. So, does anybody else have a question or some feedback to Sirk? Well, then we go. I was jokingly saying before the grand finale of today. And that is truly a very different.
It was a joke. Now I'm heartbroken.
Sorry?
Now I'm heartbroken now that I know it was a joke.
Well, there's always some truth in every joke, right? But no, I really like your project, and it's a very futuristic project, I would say. And but let me not spill the beans and let you do the presentation. So enlighten us.
Thank you. Just 1 second. Okay, got it here. I'll just share the screen. Okay, you can see we've been starting to fiddle in with a bit of design here.
Beautiful logo.
So, project's name is called ZRush, and it's a hybrid control system for robot swarms. Oh, by the way, I would like to introduce you to Max, which is on the call. He's a co-founder of this project, and we're working together on developing this and making this a reality. So, what is this control system? Basically, what the idea originated from video games, specifically RTS games like StarCraft and Age of Empires. I don't know if you've ever played them. If you haven't, give it a try. They're great. Why did we start from those games? Because basically what these games do is that they allow you to control a very large number of units at the same time, and it's proven to work. Like, people are able to do really complex things and really complex actions with like 100 units, maybe even more. And they do this by controlling them in groups, by making them move, explore the area, take actions. So it's a proven way to show that a human can actually control a very large number of units. We wanted to transpose this in real life and apply this to actual physical robots. So instead of having controlling like virtual units in a video game, you actually control these swarms of robots with a similar style of interface. So what we want to do, first let me just talk a bit what is robot swarms. Basically, it's a very new area of research. It's not used too much in the industry yet, and it's basically taken the ideas from real life swarms, so especially swarms of insects or a flock of birds. And what it does, it's a study that wants to mimic their actions, the way they move, the way they communicate with each other, and apply it to robots. So we're talking about smaller robots than what we think when we think of robots. So if we think about Sophia, or if we think about the dog, that those big robots, those swarm robots, would be really small in comparison. But what are the benefits of this? The benefits is that you're basically dividing your budget from one robot to, let's say, 100 or 1,000, which being smaller they are, it means you have a more scalable system, and the main benefit is scalability, but also fault tolerance. So where a robot goes into, let's say, a collapsed mine, and after 10 minutes it falls and it breaks its arm, the project's done, you lost 100K or something, and you have to restart from zero. Here, the robots go in, if 50% of them gets destroyed, stop working, the other 50% will still be able to finish the task. Obviously, there's a limit to that. If you're left with 2 nano robots, they won't, but they have a very high fault tolerance because they can break, they will take longer to do the task, but they will still do it. What are the current problems? I'm sorry, should I don't know if there's some questions, but if they are, I don't see them, so if you can just stop me. So what are the problems of this now? So now they're not really used in the industry. They are mostly used in a research context, and the reason for that is that they're not really reliable. So basically, the research is focusing on making those swarm behaviors, swarm algos, more reliable. At the moment, there is a bit of a problem in making them automatically finish tasks. It's also hard to test in real life environments, and also the communication between robots is something that needs to be worked on. These work in like dangerous environments, underwater, collapse sites. There's not the best connectivity, and they always need to know where each other is. So what's the solution? The solution is basically to say, okay, since the automation of these is not great, we want to put more decision-making and more control in the hands of the humans. So you would have operators that control these. You would have some automated tasks. So if you say explore an area, you wouldn't have to manually say everyone where they go. They would actually be able to explore an area in an intelligent way, but you would always have the human monitor them and see them. So, I am referring, nanorobotics is a part of this. This includes nanorobotics, but really nanorobotics is more, from what I understand, it's like, they are smaller than this. They're the ones that work, you put inside your body. This is more about doing actual physical tasks. So you can have swarms of drones, you can have swarms of nanorobots that lift things or that go and recover things, or they can be used for search and rescue. They're a bit different. Okay, so what do we want to build? And this is the dream project. We want to build this control system. What it does is you got your robot swarm. The robot swarms is equipped, so every robot has got a set of sensors, and they will be able to, from those sensors, we want to reconstruct a map on the interface of all the environments so that the operator sees exactly what's around the robots and can control them. At that point, the operator will send actions back to the robot, and the robot would perform those actions. Here I got a full list of features that we want to put in the robot. A lot of them are inspired by those games, but the idea is to have, as I said, extreme control, be able to control full groups, subgroups. We are only providing the interface, that's the idea. So we want the interface to be compatible to any kind of robot swarm. We want it to be configurable to the possible actions, to whatever. Whether they're drone, aerial, terrestrial, aquatic. And we also want a real-time alert system that tells us what's going on, that tells us if some robots are in danger, that tells us if some robots are switched off. So we would have kind of all of these features in, and we also want to incorporate a learning of the robot. So we want to assist also the research on autonomous movement of those robots and actions of those moments of those bots, because we would be able to collect a lot of data from operators and transform that into a learning system. I'll go really quickly through this because I think it's a bit out of scope of this grant, but we basically want to be a B2B business. We want to rent out as a service the control system. We'll partner with someone who provides the robot swarms, who builds them, and that's the idea. We just go with our partner, we provide the software, the partner provides the robots, and we solve all of your problems. So why does this make the world better? Well, it does if used in a good way, a bit like all things that have the potential to be dangerous. It doesn't if it's used in a bad way. We want to use it in a good way. I won't lie, a big application for this is in the military. We're not really interested in that. We're interested more in stuff like in agriculture, in relevation of like terrain, environments. You can use swarms of drones to analyze the levels of carbon in the atmosphere, and that would be way more efficient than just sending 10 of them, right? If you send 100 of them, because they can cover wider areas. They're also really useful in dangerous environments where humans can't go and where even big robots can't go because it would just break, like collapse mines, explosion sites. There have been some test scenarios of these robots used in emergency search and rescue missions in zones of war where explosions were set, like where explosions took place of bombs, and the robots were sent to find survivors within the rubble. So these are the kind of use cases that can be done. We think that swarm robotics will be a big thing, and we think that this will help start it out. If no ifs, it will. Okay, so what's in for SingularityNET? We unfortunately can't do with 40K all of this. We can do a part of it, and what we want to do is this 3D AI mapper. So basically, the reconstruction of the environment that's surrounding those robots into a something that you can see on the screen, so that you can control these robots in. So what we do, we want to, even here, we're going to have eventually a lot of mappers because they need to work on various sensors. They need to work maybe underwater, in the air. For now, we are releasing the first one, which would work with cameras and GPS, and it would be in a non-aquatic environment. We're actually thinking on an aerial environment, so using drones. And what we're doing is basically we are taking, we have those cameras that move independently, and we need to stitch all those cameras together as they move inside a single map and pinpoint where each of these cameras is at every moment to simulate the robots actually moving and the possibility of those robots moving in different directions. So this is not connected specifically to robots. It's inputs cameras and outputs the whole environment. Obviously, this would get, once this thing goes live or even in testing, it would produce a really high number of API calls, at least for our use case, because we need to go real time, hit this 10 times a second, 100 times a second to get all the information in. Then we have a bit of a sneak peek, maybe if you ever do another round or a future for this. And we already have this idea. As we said, we really would like to develop a behavior, like have a swarm intelligence learn from the operators. And I think this would be a really cool use case to add in the SingularityNET platform, to have this system that learns how to control swarms of robots. So basically the autonomous movement, the autonomous behavior, the exploration, and all of this. It's on a future stage. We need to actually have the robots, or at least, we need to be further away from this. But okay, this is the dream. If we ever become big, we want to have a product ready on year 2, start partnerships with year 2, maybe eventually become even a robotics company that builds the robots. And that's it. Thanks, everyone. And any questions?
I think there are lots of questions, Alessandro. I saw a number of them already passing by on the chat. Let me start by a first one. I think you're building the software for a solution that also includes hardware. And that is also a risk, right? Because you also require others to be able to create hardware that is fitting for your software. And I assume that you also are hoping that these hardware manufacturers are then relying on your software and not making their own.
So on this second point, they could. I know that for this specific use case of swarm robotics, I don't think that many robotics companies are doing their hardware for swarm robotics. I don't even think they're producing swarm robotics. So the idea is that we want to get a bit before the market, because these are not really a thing. I feel like as of today, it would be really hard for me to go somewhere and try to sell this.
Yeah.
But I think that in 2 years, it will be big, or maybe 5 years, or it will pretty soon. So the idea is to get there, pretty early, maybe partner with a startup. I know a few people in the robotics industry. I already spoke with a friend of a friend who started a startup in hardware robotics, and they would be interested in this kind of thing. So yes, maybe some companies will already, but I know that, for example, even in drones, so the closest thing I could find to competitors to this is people who do like fleet management systems for drones. We're talking about a lower number, and we're talking about not real-time control. It's more like kind of a radar, a control station of an airport, it looks like. And you see where maybe if you have 10 delivery drones automated, you can track where they go in and what the status is. Probably, if you're like Amazon or something, and you got to deliver parcels. And for example, all of these only produce software, and they have clients. So it's not the company that does the drones that also does this. It's a separate one. So. Yeah.
So it would also be possible to use off-the-shelf drones and then use your software to control them, and that way create a swarm.
So yes. So that's probably how we're going to test it in the first place. Just get buy 10 cheap drones and try it out with that. But obviously we would need to configure the system to those drones.
Yeah. All right. What I also like is your first application on the platform, which seems like a really generic use case by having camera images from all kinds of directions, and then having the intelligence, not even just directions, but also locations, close and far away, etc. And then having the intelligence to stitch all that together. Seems quite complex to me, but also something that I can imagine are lots of use cases for.
Nice. Yes, it's pretty complex. We're working on it, and hopefully we won't have things that stop us. So,
Robert, didn't you also have the option to apply your algorithms to 3D subjects?
They are best suited for generating 3D objects. For example, you could use it to evolve some forms of wings of a plane and stuff like that, but it's not really useful for 3D mapping, I think. But I would also have a question about the 3D mapping. Do you think it would also be possible to use just a single smartphone camera to, for example, map your house? Or is that a different use case?
So for the moment, I think the first thing would be we are trying to aim at not selling to retail individuals, but have a control system for large-scale products. Because I feel like putting this on a phone, so for one thing, there's companies who already do this. So we have way more competition. If you want to control one drone from your phone, that's super, like you can get that now. And we don't really want to enter in that space. And also I mean, personally, I rather much prefer B2B rather than try to go full retail and try to understand what people like and what their trend of the moment is. And, you know, I'd rather focus on large scale projects. I also can imagine that for now, I don't really see why would someone really need a full swarm to do what, like to cut the grass in the house. I don't know. You can just get one robot lawnmower, right? And you don't really need a swarm and have it's kind of.
I mean, one use case I could think of is on construction sites. I think they let dog robots run around to document what has happened after one day of work. And I guess they are quite slow and it takes a lot of time and you have to be careful that nobody steps on it and stuff like that. So maybe if you could use a swarm and do it in a shorter time, that could be interesting for such companies.
Yeah, that would be cool. That's definitely something.
Yeah, that also brings to mind surveillance, right? Because what you're then doing is surveillance. And in this case, it's a beneficial way of surveillance. But yeah, the image in my mind, also with these futuristic science fiction movies, etc., where small bees are everywhere, or even smaller robots that film everything that you're doing, etc. So would there be a way to prevent your services and tools being used for those kind of use cases?
So we would, the way I see it is that we would provide the operators. So we would provide the system with the operators, so people trained in using this. I'm not, when I say like that it's an intuitive and easy to use system, I don't mean that, you know, you go there and the first time you're able to control it. It's kind of like, you need to learn how to do it. It's doable because we know that it's kind of like playing those games. You start the first time, you're not going to do anything. So you need someone who knows what they're doing and who trained a bit. At that point, you know, someone says, we want to hire you to go and start a war. We can always say no. You know, eventually someone will build, if they want, some other company or some other person can build this kind of stuff for bad, negative purposes. And I guess that's just the way it is. It doesn't really change. I'm thinking this is part of a, like, we decide who to partner with, we decide who to sell the project to, we decide on what projects to participate. and we know what's going on. It's not like we're given the system and
at least we are prepared when the war of the swarm drones is starting. Then we also have a good side here to protect us. I also see that there are people who would be very interested in a lawn cutting swarm, by the way, and a pool cleaning swarm. Natasha, I see a lot of questions here, so maybe you want to comment?
I think some of them have been answered. Okay, you're referring to nanorobotics, kind of answered. It's like a sub part of this. I don't know this about digital twins. I don't know what that is. Would my swarms be controlled by human directives? So yes, they would be controlled by human operators, not everything. So for example, if we say explore an area, at that point you kind of leave it there, and the robots would do would use the swarm behavior to explore that area in the most efficient way. But we always want to have the ability of, if someone goes in, basically it's kind of like you don't want these robots to lose track of what they're doing or not be able to do something because of some obstacle or because of something. So we want someone that monitors, and that in cases where the swarm intelligence is not working, they just manually perform the actions.
Personally, I can see some user interface coming along where you use that kind of lawnmower man thing with your gloves, and then you control it like that and steer it. And
yeah,
I can totally see that. But maybe you need to go the third round and the fourth round before we have that.
Oh yeah, definitely.
Yeah, but I think it's cool that you have this vision. I think it's cool that you are using that fund also right now to start your business on something which is has a risk in it, but that we give you the opportunity now to pursue this and to start this. And what I also think is cool, that even though you have this bigger solution in your mind, that you're starting with one part of that, and that this first part is already a useful service on our platform. So I think that is how this all comes together, and that is also how our platform is meant to be. Not for complete end-to-end solutions, but also for building blocks, like we already saw a few, that can be used by others as well. And maybe that will also give you some business opportunity if you can just start selling those services and get some revenues from that already before your full proposition has matured. So I think it's cool, Alessandro. I'm a big fan. Anyone else has some questions, or maybe questions to Robert, since we're now in overtime anyway, so no, I think that ship has sailed by now. But yeah, then let me say thanks a lot for all of you for these presentations, and thanks for all the preparation that went into it, and seeing you talk about it and explain it, etc., always makes it come to life much better than just reading a proposal in our portal. Even if you put a lot of attention to it, etc., just seeing it and hearing people explain it makes all the difference. So yeah, I hope the community will think the same thing, and I think we will all be following you in the months to come and see what it will result. Exactly. All right. Thanks for that. I think this is a wrap. So thanks a lot.